Hello! One of the fields where special relativity is used every day is in particle physics. Because we can accelerate elementary particles at speeds near to that of light, we need to consider relativistic effects of time, mass, and energy there. Because of the relation between energy, momentum, and mass, particle physicists use the same unit to make reference to them. They use MeV, megaelectronvolts, or GeV, gigaelectronvolts. 1 electron volt is the energy that an electron gains when it is accelerated by an electric potential difference of 1 volt. Consider one particle in a reference frame with energy of 5 GeV and a momentum of 3 GeV. Strictly speaking, it would be 3 GeV over c, but in relativistic units, momentum and energy and mass, they are measured with the same units, with units of energy. So you can talk about momentum measured in GeV over c or just GeV, and you can talk about mass measuring GeV over c squared or just GeV. When you want to go back to SI units, you just multiply up and down by c wherever you need it. So, what is the energy of this particle in a reference frame where its momentum is 4 GeV? To find it, we use the energy momentum invariant we just found. We use that E squared minus Cp squared is equals to E prime squared minus Cp prime squared. We solve for the energy primed, we take the square root and substitute. Here we have square root of 25 minus 9 plus 16, which is 4 times square root of 2 GeV, 5.66 GeV. If we want to calculate the rest mass of this particle, we just use the same equation again, but now we calculate E squared minus Cp squared. So m is equals to the square root of E squared minus Cp squared over c squared. This is 4 GeV. Again, you can find this result written in 4 GeV over c squared or just 4 GeV. Now, what is the relative velocity between these two reference frames? Well, from the equations of transformation of the energy momentum from one reference frame to another, from the first one we can substitute and write gamma explicitly and solve for beta. 4 square root of 2 is equals to gamma 5 minus beta 3, and beta is 0.9177.
But I need a nuclear reaction to generate the 1.21 gigawatts of electricity.